So the idea is going to be, what is the area between two curves? Area between, okay, the area between two curves or two graphs. Two curves. You know that the integral, definite integral, geometrically can be identified as the area under the curve. So we recall that we know the area under one curve. Okay, recall that. The area of a region, that's the one that we use to introduce the Riemann integral. The area of the region bounded, okay, area of the region bounded by the graph of a positive continuous function, like y equal to the f of x from x equal to the a to x equal to the b. That was exactly the definition of the definite integral. Is given by simply an integral. A equal to integral from a to b, f of x, d of x. Okay, that's what we know so far. So this is going to be the graph that we have. Okay, that would be the, sorry, just something about that. Okay, so this is going to be your graph, and this is the region in question. Okay, so that's going to be the area that we are going to be interested in. And as we did it the other night, this is just simply is going to be integral from a to b, f of x dx. Your function must be positive because the area is positive number. So it's usually we consider the one above the x-axis. But in applications that we are going to have, sometimes we are going to have two curves. We have two functions. These two functions would have some intersection, and their intersection is going to be a region. It's going to be a region bounded by the intersection of those two graphs. And you want to find the area between two curves. Okay, so that's the thing that we know it. Now the one that we would like to extend is the following. Now suppose we have two functions. Okay, suppose we have two functions. Okay, f and g are going to be continuous on the closed interval of a comma b. When we graph it, one of them is going to be on the top of the other one, okay, above and below, we got it. So suppose two functions f of g are continuous on the closed interval of a, such that you have to identify which one is going to be on the top. Okay, such that suppose f of x is going to be the top function, is greater than or equal to the g of x. Okay, g of x for all x in the interval of a and b. So this is going to be a situation that we are going to have. This is it. So we are going to have one function is going to be on the top. Suppose this is going to be the top function. Okay, the top function is going to be f of x. We're going to call it y of the top, which is going to be f of x. And then we are going to have the g of x, which is going to be the function right at the bottom, if you like. So this is going to be This is going to be the second function. So this function is going to be y of the bottom, if you like. We call it g of x. Okay. So there is going to be a region in between. You see, this region is the one which is going to be between these two curves. And suppose this point is going to be A, and this point over here is going to be B. Okay, so we have two functions. In this case, they intersect, and then there is a region between these two curves. So we want to find the area of this region. Okay, it's clear. You find the area of the top, you see the area of the red one. This area would cover everything right up to here. Then you minus, okay, then the area of the green one, and then the curve. So when you find the difference exactly would be the one that we are going to know, you are going to have here. Okay, so suppose that two functions given to with this information that we are going to have, then the conclusion is going to be, if you want to find the area between these two curves, so the area and the area of the region, the area of the region between, it's going to be between the curves. I officially introduced those notation. The y of the top is going to be f of x, and the bottom one would be g of x. The reason is your result must be a positive number. So if you miss the top and the bottom, if you switch it, the result would be a negative number. That's why we want to make sure that we get a no. It's not a big deal, of course. So the area of the region between these two curves is going to be given by, naturally is given by the difference of those areas. So this is it. So your A, the area of the region, is going to be integral from A to B. Okay, integral the function on the top, y of the top, minus the function at the bottom, y of the bottom, and then the dx. In this case, it's going to be integral of the function on the top is the f of x minus the function at the bottom, g of x dx. See, it's a difference between these two areas. Any question? In practice, we can identify which one is going to be on the top. But if you want to play it safe, you can use the absolute value here. You put the absolute value around it. You integrate it without the absolute value. If your result is positive, so that's fine. If your result is going to be a negative number, you are going to say, oh, I consider the absolute value. So again, you get a positive number. Okay, so you have two choices. You prefer this one just to show you how you identify which one is going to be on the top. But otherwise, you can use the absolute value to get this one. So I just write it down that one for you too. So I write that if you want to play it safe, you just can say that, forget about the top and the bottom. You can say that the area is going to be integral from A to B, just the absolute value of f of x minus g of x. Okay, the difference between, because the function that's going to integrate is going to be the difference. Okay, so this is how we are going to, do it to get these numbers. Okay, any question? Yeah, so that's it. Two functions would be given to. We want to find the area between two curves. Your problem is going to be the point that we're going to intersect. Most of the time, these points are not going to be given to you. If it's not going to be given, so this point is going to be intersection of the graphs. So you have to find the intersection first. For the intersection, you put these two equations in a system of two equations, two variables. And most of the time, the substitution method would give you the point of intersection, okay? Otherwise, it's it's going to be a nice one. So I'm going to give one example. We have one on practice one, we can check it. and it's going to be just one define node. We repeat it again. Okay, any question? Example, straightforward one. You want to find the area between these two curves. Find the area. Okay, find the area of the region. Bounded by the graph. Okay, bounded by the graphs of this function. The functions are f of x is equal to the x squared minus 4x plus 3. That's the f of x. Then you have the g of x, and the g of x is equal to negative x squared, plus 2x plus 3. So that's going to be the one. You can graph it if you like, but you don't need it to get which one is going to be on the top, or just you can use algebra to take care of it. But you have to find the intersection point first. Okay, the limit of your integration is going to be their intersections. So the solution is going to be, these two functions are parabola, and when the coefficient of the x squared is positive, it's going to be, it's going to be open upward, and when it's going to be negative, it's going to be open downward. So roughly, this is going to be the region that you're going to have. But you have to find this intersection first. Okay, so for the solution, find the points of intersection. Find the points of intersection. So this means you are going to put them into the system of two equation, two variables. So it's going to be y equal to x squared minus 4x plus 3, one of the equation, and the other one y equal to the negative x squared plus 2x plus 3. Substitution method, you let these two equal to each other and you solve for x, and then you do that. Okay, so it's going to be x squared minus 4x plus 3, and that would be equal to the negative x squared plus 2x plus 3. Since you have the x squared, you have to move everything to one side of the equation and use factoring to take care of it. Okay, move them into one side. So you have the x squared minus 4x plus 3. So this would be a positive x squared minus 2x minus 3 equal to the 0. Carefully simplify it. So x squared and x squared would be 2x squared. Okay, that's 2x squared. Negative 4x and negative 2x would be negative 6x. And in this case, the 3 and the negative 3 will be canceling out. Okay, so that gives you equal to the 0. Then factor out the 2x. We factor out the 2x, so that gives us x minus 3 equal to the 0. We have two solutions. Okay, 2x equal to the 0, that gives you x equal to the 0, one solution. And the x minus 3 equal to the 0, give you x equal to 3. So you are going to integrate from 0 to 3. You see, that gives you the limit of integrations. Any question? Now, if you like, you can check to see which function is going to be on the top. So to check it, you just pick one number between 0 and 3 to wrap it into the function. Then you will find out the y coordinate of each one is going to be higher. Okay, so if you like, check a number, something like x equal to 1 in these two equations that you have. If you put x equal to 1, so your y would be 1 minus 4 plus 3, which is equal to the 0. And if you put it in the second one, So that gives y equal to the -1 plus 2 plus 3, which is going to be 5, 4. Okay, as you can see, 4 is bigger than, okay, 4 is going to be bigger than 0. So this means this would be y of the top, and this would be y of the bottom. Okay, so the one on the top is the second one, and the one down the bottom is going to be the first one. You know, that's the first easy way to check it. Again, you know, if you miss it, it doesn't matter. You get a negative number for the area, so area cannot be negative. You change it to the positive. But a number between 0 and 3 would do it for you. A number 0 and 3, you put it into the equation of the functions. So y equal to the 4, y equal to the 0. So 4 is bigger than 0. So the second one is going to be on the top. Okay, now we prepare everything. Now we find the area. Area integral from 0 to 3. Okay, integral from 0 to 3. 0 to 3, y of the top minus y of the bottom, the function, dx. So this is going to be integral from 0 to 3. You bring the function. Y of the top is a negative x squared plus 2x plus 3 minus, you better open up the parentheses to get the second one, which is going to be x squared minus 4x plus 3. Everything dx. If you simplify this equation, you must arrive at the one that you got over here, 2x squared minus 6. It may be 2x squared minus 6x, or maybe 6x minus 2x squared. Depends which function is going to be on the top. Okay, so we have to check it. So this is going to be the integral from 0 to 3. Okay, so that gives you a negative x squared plus 2x plus 3. Apply the negative sign, so make it the negative x squared minus plus 4x minus 3. Okay, all dx. And if you simplify it, so it's a negative x squared and negative x squared make it to the negative 2x squared. And the 2x and the 4x would be 6x. You see, you didn't get exactly 2x squared minus cx, but you get the 6x minus 2x squared. Okay, it's going to be, it depends which one are going to put on the, okay, on the top. Now it's easy to integrate it and get the final answer. Okay, what's the question? This is going to be the one. Yes, it must be the function on the top, yes, because this must be a positive number. So you are going to have a positive number if you put the bigger one first. Okay, otherwise you get a negative number. Okay, now integrated is usually a polynomial. You know, the usual integration would do it for you. So that would be what? Negative 2 is a number, so that would be x cubed over 3. And this is going to be a positive 6. And that would be x squared over 2 to be evaluated from 0 to 3. Remember, you have to integrate it first. Some people, they get this part, they don't integrate it. They substitute the number. No, you have to integrate it first. Okay, we cannot simplify it, so that gives us a negative 2/3. Okay, negative 2/3 x cubed. And over here we can simplify, so that gives us a plus 3x squared from 0 to 3. Substitute. So if you substitute over here, so what we're going to have, we have a negative 2/3. We put x equal to 3, so that gives us a 3 cubed, and the plus 3 times 3 squared. And if you put the 0, everything would be 0 because of the x. So 3 cubed would be 27, so that gives you negative 2/3 times 27, and that would be a 27 again. So 27 divided by 3, that gives you 9. 9 times 2 would be 18. So it's a negative 18 plus 27, which is 9. So the area under this area between these two are going to be 9. You know, there is no unit, but if it's happen to be unit, so it's going to be whatever unit it is going to be a square. Okay, so that give you the area between these two curves. Any question? So that's going to be the one. The only thing is that the functions that we have always in this case, you have the, the function is y equal to the f of x. So y is the function of x. Sometimes they switch it. You see, it's like switching the x and the y coordinates. So they may give you something like x equal to, okay, x equal to the 1 minus y squared. So in that case, everything would be the same, but you have to switch the x and the y. So you integrate respect to the y if you like. Okay, so that I just give you a remark, and that would be the second case that you may, you may be given. So it may not be, you may not be able to solve for, getting the function in this format that you wanted. Okay, but you don't need it. So let me give you that remark. Any questions? Really straightforward problem. Make sure the algebra is all right here and don't miss any number. When you integrate it, this is a difference. This must be a negative. You must use a parenthesis to get this part. When you simplify it, you must integrate it. If you don't integrate it, you are not done with the integral. Okay, so that is the first case. Give you the other case too. Okay, this is going to be a remark. If they switch the variables. Okay, if they switch the variable, this is going to be the situation they're going to have. You see, this is the one that you did have. You see, this is the first case. If you switch, it means you are going to rotate. You are going to rotate the XY coordinates. So you just look at these two curves in this format. So I'm going to show you how the formula would be changed. So if the functions, because it's going to be used in application, so sometimes it's not possible to switch it again. So if the functions this time are going to be x equal to, okay, x equal to the, let's say, f of y, and x equal to the g of y. So the functions are the functions of y are continuous, are going to be continuous. On interval would be different, something like c and d. Okay, such that again one of them is going to be greater than the other one. F of y is going to be greater than equal to the g of y. G of y for, okay, for y in this interval, c and d. Okay, so what's going to be the shape of your region? You see, look at the region now. If you graph it, your curve is going to be in this form. You see, this is going to be one of them, for example. And this is going to be the other one. See, because you switch the x and the xy coordinates. So if you want to think about that top and the bottom, you see, the top one is going to be this black one. So this black one now is going to be the one to the right. You see, again, it's not a big deal, but if you want to get a formula. So this part, this black one is one to the right, which is the f function, okay? So we say this is x of the right, which is going to be f of y. And this red one, okay, this red one is the function to the left, x of the left, which is going to be g of y. Again, if you want to talk about this type of idea, just find the difference, integrate it. To start with, you just put the absolute value around whatever quantity you have. And if your result is going to be negative, you say, oh, I did use the absolute value. So they just make it into the positive. So if you have it in this format, then you can say that the area. So then the area between those curves, okay, the area of the region, the area of the region bounded, okay, bounded by the curves, okay, by the curves. This time is going to be the curve x to 1 to the right and 1 to the left, which is going to be g of y, is going to be given by the formula. Is going to be integral from c to t, the difference. The difference, the one to the right is the on the top, minus the one to the left. But this one is going to be dy, because your function is a function of y. So you integrate in respect to the y, which is equal to the integral from c to t. Okay, that would be f of y minus g of y, then dy. Okay, so if they if they change the variable, so you change your you integrate respect to the y rather than integrating respect to the x. Okay, any question? So that would be type 2, but we give you one of them, but we want to make sure you know it. So this is going to be the example that we are going to have. So we want to find the region, find the area. Okay, find the area of the region between two curves of the region between these curves, between the graphs of what? Two graphs. This part is f of y is equal to the 1 minus y squared, and g of y equal to y squared minus 1. Again, two parabola, but the direction is different. Okay, are you ready? Just a point of intersection again for the solution. So we are going to intersect it, find the points of intersection, So your first graph is going to be x equal to the 1 minus y squared, and the second one would be y squared minus 1. Substitution method, let the quantities to be equal to each other. 1 minus y squared equal to the y squared minus 1. Okay, 1 minus y squared equal to the y squared minus 1. So we pull everything to one side of the equation because you want to solve for, okay, solve for y. So you have the 1 minus y squared. So that would be minus y squared plus 1 equal to the 0. So that gives you negative 2y squared. And that would be 1 plus 1, which is 2, equal to the 0. You have to solve for y. You can factor it, or you can move it to the other side, use y, find y squared, and then take the square root, whatever you feel comfortable to do it. Okay, so I can move one of them to the other side, say 2 equal to the 2y squared. We divide by 2, that gives 1 equal to the y squared, which is the same as y squared equal to the 1. So we take the square root, y would be positive negative 1. So y is going to be between negative 1 and positive 1. And that would be the limit of integrations. Any question? It's very similar to the first part, but your variable is going to be different. If you like, you can check a number between negative 1 and 1 to see which function you are going to put first. Okay, so we are going to call it checking. So it's a y between. Any question? I want to go to the next page to continue. Okay, again, you can integrate the difference and then decide at the end, or just decide right no. So the interval that I'm going to work with is going to be y between negative 1 and 1. So I'm going to check to see which function are going to put first. So the easiest point is 0. Then you can check. So you check into your first function. You see the function was 1 minus y squared, x equal to the 1 minus y squared. So if you put the 0, so that give you 1. And the other function was x equal to the y squared minus 1. If you put it over here, so that give you 0 minus 1, which is a negative 1. So this goes first. Okay, so you can call this one x to the right, and this is going to be x to the left. Or just write, that the first function 1 minus y squared. Okay, question? Even if you don't check it, as I told you, just integrate the difference. If it's a positive number, you got it. If it's a negative number, change it. So not a big deal. But the area now is going to be integral from negative 1 to 1. The function to the right, the bigger one, minus the function to the left, the smaller one, but the dy. So negative 1 to 1. The function to the right is 1 minus y squared, minus the function to the left is y squared minus 1. So that give you dy. Again, you subtract. It's going to be negative 1 to 1. So we have 1 minus y squared, apply the negative sign, negative y squared plus 1 dy. Go on. 1 and 1 would be 2. 2 minus 2y squared. That is the quantity that you have to integrate. But we integrate in respect to the y, so the 2 would be 2y minus negative 2 is a number. You add, move up the power, and you have to find it from negative 1 to 1. And nothing to simplify, so that you get 2/3 of the y cubed from negative 1 to 1. And if you substitute, if you put y equal to the 1, so that give you 2 minus 2/3 minus parentheses, replace the y by negative 1. So that give you a negative 2 minus 2/3 negative 1 cubed. Okay, so what's going to be the result? It's going to be 2 minus 2/3. Inside is a negative 2. Negative 1 cubed would be a negative 1. Negative would be positive, so that give you a positive 2/3. So you have a 2 minus 2/3, negative positive, plus 2 minus 2/3. So the 2/3 and the 2/3 would cancel out. 2 and 2 would be 4. So the area in question is going to be 4. And you're done. Okay, so it's a 2 case that we're going to have. You integrate respect to the x. Sometimes it would be possible, to go back and switch it. But in this case, you can't do it because x is equal to 1 minus y squared. If you want to take the y, so you are going to have a positive negative, and things would get very very complicated. Okay, so that's going to be the area between two curves we're going to have. Okay, any question? So you have 2 questions on your review. 1 question, it's a question number, okay, number 5. Number 5, A and the B. In fact, the part A, I think, is the same as this one. The part A is the same as the first part that we did. So I do the part 2 for you, which is different. Okay, 5B on the review as our example, because the 5A is exactly the same as the one that I did. And we give you 1, of course, not 2. So this is a 5B on the practice. Okay, practice quiz number 4. We want to find the area between this region. Okay, the regions are x equal to 4 minus y squared. Okay, and the other one is x equal to the y minus 2. One of them is a curve, the other one is a straight line. Okay, and you want to find the area between the 2 curves. Okay, question, are you ready? Point of intersection first. You put them into the system of the equation, x equal to the 4 minus y squared, and the x equal to the y minus 2. Substitution method. So let both of them to be equal to each other. Okay, so y minus 2 equal to 4 minus y squared, or the other way around. You have to solve this equation, so you have to move everything to one side and try to do the factoring method to solve it. So that's going to be y minus 2 minus 4 plus y squared equal to the 0. Simplified, put it in the order. Standard one, so that give y squared plus y, and that would be negative 2 minus 4, negative 6 equal to the 0. So to find the y, we have to factor it. So to factor this one, we need 2 numbers with a product of 6 and a difference of 1. So the number is going to be y plus 3 times y minus 2 equal to the 0. So we have 2 solutions. Y equal to the negative 3 is one of them, and y is equal to 2 is the other one. So we are going to be integrating between, okay, between negative 3 and 2. This is going to be the limit of integrations. Any question? So be prepared for, it's going to be quadratic, but it can be solved easily. If it's getting complicated, you probably miss a number, miss a sign, because this must be a nice number. You see, if you cannot solve this one, probably you miss something, okay? And so we can check if you like to see which one is going to be on the top or to the right, to the left. So a number in between, again, 0 is good. So put the 0 into these 2 equations. So we have the x equal to the 4 minus y squared. It's going to be 4 minus 0, which is 4. Okay, checking the second one. So the second one is the y minus 2. So that gives 0 minus 2 equal to the negative 2. So this is going to be on the top. Okay, so in this case is the one to the right. Any question? So that give you, then you'll be safe. When you integrate it, the result is going to be just a positive number, and you don't have to worry about it. So let's go for it. This is it, the area. So the limit of integration is from negative 3 to 2. The function to the right minus the function to the left. So it's going to be dy. So carefully substitute, it's a 3 to 2. The function to the right is 4 minus y squared minus, open up the parentheses. The second one is y minus 2 everything dy. Apply this negative sign, make sure you apply to both terms. So it's going to be -3 to 2. That's a 4 minus y squared. And that gives you a negative y plus 2 times the dy. Okay, combine the like terms. It's a -3 to 2. So for the like terms, you have, okay, you simplify those numbers. So what we have, 4 and the 2 would be 6. It's a 6 minus y squared minus y all dy. Okay, so you must get this one, you know, you get similar, same one or negative of this one. In this case, you get the negative y squared, negative y plus 6. Now, carefully integrate it. Integrate, okay, so this is going to be equal to, the 6 would be 6y minus, this would be what, y cubed over 3. And this would be y squared over 2. Okay, then you have to evaluate it from a -3 to 2. So substitute. We put the 2 first, going to be 6 times 2 minus 2 cubed. Okay, 2 cubed over 3 minus 2 squared over 2. So that's when we put the 2. Okay, it's going to be minus, then we have to check the -3. Make sure you use parentheses. It's going to be 6 times the -3 minus -3 cubed over 3 and the minus -3 squared over 2. Okay, this is it. So it's going to be equal to 2 cubed would be 8. So that gives you 8 third. Okay, 2 squared would be 4. 4 divided by 2, that gives you 2. This is the one. Minus inside, 6 times 3 would be -18. And a -3 cubed would be -27. -27 divided by 3, -9. There is a negative sign here that gives you a +9. And -3 squared would be +9. So that gives me 9/2. Okay, any question? So be careful with these negative numbers. Okay, make sure you get proper sign. So go on to simplify it. So that gives you 8 third minus 2 minus inside. -18 plus 9 would be -9 minus 9/2. So it's going to be 8 third minus 2, a +9, and the +9/2. Okay, +9/2. So -2, that gives you 7. Okay, so it's going to be 8. Let's see what we got. So far it's going to be, just double check this one to get. Okay, so we just move on. So I just want to make sure I didn't miss anything over here. So I have 2 minus, oh yes, it's from -3 to 1. Oh yes, and there's something else. Okay, so this is it. That gives you 8 third. 8 third plus 7 plus 9/2. You have to find the common denominator to get this one. The common denominator would be 6. So this is going to be 6. 2 times 8, 16. So that's going to be 6. 6 times 7, 42. And this would be 6. That gives you 20, 27. Okay, so we add them together and that gives you the final answer. So that's a 6. 7 and 2, 9, 15. So 2 and 1, 3, 7, 8. 85/6 is going to be the final answer. Okay, so be patient. you are going to be some fractions, you know, when you get these type of functions, but it's not a big deal, and you'll be able, you know, to take care of it right away. Okay, any question? So area between two curves, one for this quiz and one for the final. We have a couple of them in the final review, then we are going to take care of it. Okay, question. Now that the method of integration by parts, okay, that's easy method. We talk about it, and then we get 2 problems on that one too. Okay, for the final. And let's see. This method is quite a popular one, method of integration by parts. And in your field, you have something, you know, in supply demands that you want to predict a kind of information that you needed. Okay, so I have to bring it in a notebook for this one. Okay, so what is the idea of integrations? There are many methods, you know, to find the integral of the functions other than the one that you did. But in your case, you just need the substitution method, the integration by parts methods. Okay, so that's going to be 6.1, the last section that we cover. Okay, so what is going to be integration? Integration by parts method. Parts method. What's going to be the idea? See, there are going to be 2 functions involved when you want to integrate it. So what's the idea? Remember the product rule for differentiation? Recall that. Recall that by product rule. Product rule. Remember this one? If you have product of f of x and g of x, and you want to differentiate it. It was derivative of the first one times the second one plus derivative of the second times first, okay? Derivative of the first one is f prime of x times the second one, g of x plus derivative of the second times first. So it's going to be the first f of x, and this is g prime of x. Okay, that's product rule. Derivative of the first times second, second first. Now, what we can do is, okay, you see, I want to change it into the equivalent form for the integration. These f primes we can change it. So what I'm going to do, I'm going to solve this equation for one of these that I have here. Okay, so what I do, I'm going to keep this one on one side of the equation, and I'm going to subtract the other one. So the situation I'm going to have is going to be, I'm going to have f of x, okay, g prime of x. I keep this one, and then I subtract this one here. So that gives me f of x, g of x prime minus g of x, f prime of x. Okay, I just move one of them to the other side. Now, equivalent form is going to be integrations, or if you integrate both sides, you are going to have what? You see, if you integrate it, this would be integral of f of x, g prime of x dx. Since this is a prime antiderivative, so you know that the integral of the derivative would be just a function, f of x, g of x, and that would be minus g of x, f prime of x, d of x. So if you want to integrate both sides of the equation, that gives you this formula. And this formula is going to be called integration by parts. So in order to make it easier to remember, you see, I'm going to call this function, use an easier notation. So we call the f of x to be u. This would be u. U is going to be f of x. V would be g of x. Okay, now, then like the substitution method, du, you see du, differential of the u would be what? Would be f prime of x times d of x. dv, differential of the v would be g prime of x times dx. Go back, write this one with this notation. Let's see what you have. You see what we'll get? We get integral of f of x is u. G prime of x dx, g prime of x dx is dv. So u dv is equal to f of x is u, g of x is v. U times v minus integral of g of x is v, v du. You see, this formula is going to be called integration by parts formula. Integration by parts formula. So this means, you see, you want to find this integral, it may be complicated. But if you break it into this format, you will end up with a new integral, v du. This second one, it should be, or it will be, easier one to handle rather than the original one. So that's the idea of the integration, okay, integration by parts. To get these numbers true, okay? So let's give you an example to see how we're going to operate, because otherwise, you don't know what's going on for this one. The function is very typical. The function that you are going to see is going to be ln x, okay, or a power times ln x. X squared ln x, x to the 5th ln x, x to the 6th ln x. You're not going to do anything else. So let's try one first. Example. We are going to ask you evaluate integral, use integration by parts. Integration by parts. Integration by parts, to evaluate the integral. To evaluate the integral. That's it. So, you see this is the one on the review. Part 1 is integral of x to the 6 ln x dx. You are going to have x to the 6, x to the 5th, x cubed. See, it's very typical problem for your case. Nothing complicated. So, in general, it's good for the trigonometric function. So you don't have the trigonometric function. Now let's see how we're going to do it. You see, compare these two together. Compare these two together. You have to take one part of this integral, u, and the other part would be the leftover dv. So the one that you take it u, you differentiate it to get the du. The one that you pick for the dv, you integrate it to get the v, to be able to continue to get to the second one. Since you are going to have a very unique problem, so your choices are going to be very much limited. This is going to be your choice. You take u to be ln x. U to be ln x all the time. Why? Because it's easy to differentiate. Because you have to find the du. So take the u to be ln x, dv, the leftover. What's going to be the leftover? X to the 6, okay, x to the 6 dx. So these are going to be your choices. Any question? So for this group of the problems, you take u to be ln x all the time. The leftover is going to be dv. So what's going to be the leftover? The leftover is going to be x to the 6 dx. Now, the one that you take it to be u, differentiate it to get the du. The one that you take the dv, integrate to get the v. Then substitute in the formula and then do that. Very easy. Okay, so for this one, differentiate, find the du. Du, remember, is the derivative. If of ln x is 1 over x times a dx. That's a du. Over here, okay, over here, integrate to get the v. So v would be integral of x to the 6 dx, which is going to be what? 1 up x to the 7 over 7. Don't add the constant c. Just one integral. So this second one is going to be x squared to the third, to the fourth, to the fifth. This is going to be the one. Any question? So it's a unique choice. U to be ln x, the leftover dv. The one that you pick the u, you have to differentiate to get the du. So the du is always 1 over x dx. The one that you call dv, you integrate it to get the v. Now, write this formula. Okay, so what's going to be the formula that you have? I write it down so I can substitute. You see your formula is u dv is equal to the u times v minus integral of the v du. Substitute. U dv is going to be this one because your u is ln x and the dv is x to the 6 dx. So you repeat your integral, x to the 6 ln x dx equal to u times v. Okay, u times v, this is it. Your u is ln x, your v is x to the 7 over 7. So uv would be x to the 7 over 7, x to the 7 over 7 times u times ln x. That's uv minus integral of v du. V is x to the 7. V is x to the 7 over 7. And the du is 1 over x dx. You see? uv minus v du. You see, this second one is very easy integral to find because always this x and would be simplified. That give x to the 6. So the leftover is just 1/7. So we can, find this integral right away. Okay, any question? I want to rewrite it on the second page and then I continue. So let me rewrite it for you. It's very unique case. So this is the result that you have. You have the integral of x to the 6 ln x dx. You rewrite it as x to the 7 over 7 ln of x minus, when you simplify it, that give you x to the 6 over 7 dx. See, that's going to be, when we simplify, always this x, you see the power would be done all the time. X to the 6, 7. Now you find this integral. It's very easy to find. You know that you move after 1/7 out. So it's going to be equal to the x to the 7 ln x minus 1/7 integral of x to the 6 dx. And you just move the power up again. X to the 7 over 7 ln x minus 1/7 at the power. X to the 7 over 7. This is the end of the problem plus constancy. 7 would be 49. So x to the 6 ln x dx is equal to x to the 7 over 7 ln x minus x to the 7 over 49 plus the constancy, and then do that. There's the formula for all of them, but we don't want to use it. Okay, any question? So it's a great method for taking care of this type of integrals. Okay, the examples are very typical one that you will you will get it. You see, look at this one. This is 6 x to the 7 over 7 x to the 749 all the time. If it's going to be x to the 5th, it's going to be x to the 6 over 6 ln x minus x to the 6 over 36. One formula, but we have to do it. We have to do it to get to get these numbers done. Any question? I give another one. The nice one is this one. There are 2 types. I'm not going to give you that second type tonight. We just focus on the ln for the time being. Okay, then we talk about that one and do the review. So the typical one is this one, integral of ln x dx. That's a good one. You see, there is always a power here, x times x squared, but there's nothing. You can call it x0 if you like. Now, I told you the choices. I told you that always take the u to be ln x. The leftover dv. In this case, the leftover is just a dx. Okay, always we get the u to be ln x. The leftover is dx, it's dv only. So from this part, you have to differentiate to get the du. Always it's going to be 1 over x dx. From this side, you have to integrate. V would be integral of the dx. Is integral of the 1. You know that it's equal to the x. You're not going to put a plus c here because this is not your final answer. It's okay if you even put the c, but we don't do it. Okay, so the first part u is ln x, du would be 1 over x dx. The second part we integrated, v would be x. So the formula ln x dx is equal to uv would be x times ln x times ln x minus integral of v du. V is x, du is 1 over x dx. These two would cancel out. So we get what? It's x ln x minus just the dx. Integral of 1 is x, so it's going to be x ln x minus x plus c. That is integral of ln x dx. It's a very popular formula. Some people they memorize it, okay, to get these numbers. So it's a very good one. The other one comes with the exponential function. That takes a little bit more time, and there is a shortcut for that one. We don't want to talk about it tonight. Just want to make sure you get this one, get the idea of what's going on for this type of integration by parts, and then we talk about it maybe on Thursday for you, or when we do the review. Okay, I can give a break now. We come back and we do the problem on the practice quiz for you to prepare you for that quiz. Okay, and then we go to the review. There are a couple of more for this type of integration by parts. Okay, so it's 8:25. 10 minutes, I come back and do the review. 8:35. Okay, see you in 10 minutes. Okay. So the problem on the practice quiz. So you have a substitution method. Okay, you know that substitution method, we have 5 different functions of 5 different types, and we give you one from each. So that is a practice quiz, and keep these solutions because that's going to be part of your final review. Practice quiz number 4. So for the first part, you've been asked to integrate by substitution method. Okay, so that's going to be substitution methods. Substitution method. And you know that you have only one formula. So integral of u to the n du is going to be u to the n plus 1 over n plus 1 plus the constant c all the time except when n is equal to -1. If it's happened to be the -1, u to the -1 would be integral of 1 over u du, which is ln of the absolute value of u plus c. And if you have the e function, e to the u du is simply e to the u plus c. In all of this, d of u, so differential of the u is u prime dx. That's it. Okay, all the function that previously we differentiated using the chain rule, now we are going to integrating using the substitution method. Okay, any question? 5 types. So the type 1 is this one, part 1. It's just give you a parenthesis, a power function, if you like, 4x squared minus 3, everything to the 5th dx. Whatever it's inside the parentheses, you call it u, because you need u to the n. So in this case, if you call this one u, the result must be u to the 5th when you substitute. If you don't get u to the 5th, probably you miss something. Okay, and you have to show all the details of your substitution. Okay, if you write only the solution, you are not going to get any point for it because substitution method. Okay, because the solution now you can check it with your calculator and solution would be given to you. So you have to do the operation, remember. So we take the u to be 4x squared plus 3. That's the step 1. We find the du. You differentiate it, that gives you 8x, but multiply by dx. You find the dx, which is the du over 8x. Very standard operation for all of them. You go back and you substitute, you must end up with u to the 5th. Okay, so the substitution is here. So it's going to be integral of 8x, 4x squared minus 3 to the 5 dx. You don't have anything to substitute for 8x, don't worry, it's going to be canceled out. So over here, it's going to be u to the 5th, times the dx. The dx is the du over 8x. Now we simplify. The 8x and 8x would cancel out. So we got what we expected. U to the 5th du. That's it. You see the power was 5. So you must end up in the u to the 5th. Now action of integration, u6 over 6 plus c. You substitute for the u. So it's a 4x squared minus 3 to the 6 over 6 plus the constant c, and you're done. See, very straightforward. Any question? So that's a type 1, just a polynomial raised to, raised to a power. Okay, that's part 1. Part 2, a rational function. So in this case, we have integral of 1 over 3x plus 5 dx. When it's a rational function, you look at the bottom. If there is a parenthesis raised to something, you move it up. Otherwise, you stay where you are. You call this one u, as you must end up with 1 over u du. Okay, so if there is any parentheses, you move it up. Otherwise, you stay where you are. You take the u to be equal to the 3x plus 5. You substitute, and you must end up with 1 over u. That's, that's the general method. Question: differentiate. Derivative would be 3 times dx. You find the dx. Dx would be du over 3. Go back, substitute. So originally you have 1 over 3x plus 5 dx. When you substitute, the 1 stay the same. 3x plus 5 is u. And the dx is the du over 3. There is nothing to be simplified, but there is a leftover 1/3, just a number. You can pull out the 1/3. So 1/3 integral of 1 over u du, as you predicted. And you know that it's going to be ln u. But you must use the absolute value. Some of you didn't use it on your test. Make sure you use it. Okay, and then you substitute for u. So it's a 1/3 ln of the absolute value of a 3x plus 5 plus the constant c, and you're done. Any question? That's a rational function when there is no power here. Is changing to the, okay, it's going to be changing to the ln function. So that's going to be A and the B. Question? The third case is when there is a power, like part E. Okay, in part E, the integral is integral of x squared. And the bottom one, you have the x cubed plus 5 all squared. All squared dx. See, compare them together. Here you get just 3x plus 5, but you have something raised to the second power. So you move it up. When you move it up, it's going to be just a type 1, and you'll be able to do it. Okay, so you have to rewrite this one. It's going to be x squared times x cubed plus 5 to the negative 2 dx. That's it. That's exactly like the one that you did over here. Okay, so the inside parentheses, you are going to call it u. Okay, so your u is going to be x cubed plus 5. Differentiated. Du, derivative would be 3x squared times a dx. Find the dx. The dx is the du over 3x squared. Any question? You go back, you substitute, everything should be simplified. And you must arrive at u to the negative 2. Okay, are you done? I have to go to the next page. So to substitute for this one. So this is it. So I have x squared, x cubed plus 5 to the negative, okay, negative 2 dx. Now I substitute. I don't have anything for the x squared, but it's going to be canceled out. The inside is u to the negative 2. The dx is du over 3x squared. See, x squared and x squared will cancel out. The leftover is 1/3, a number. So you pull it out. It's going to be 1/3 integral of u to the negative 2 du. Action of integrations, you move up the power. 1/3 u to the negative 1 over negative 1 plus the constant c. You have to take care of these negatives. This is going to be sign of the fraction. U to the negative 1, you bring it down. So it's going to be negative 1 over 3u plus c. Now substitute for u. So it's going to be negative 1 over 3 times u. U is x cubed plus 5. plus 5 plus the constant c, and then u down. Okay, any question? So that's it, kind of with the rational function. With the denominator you get a power. You have different cases. You may have those rational function with the radical. It's not a big deal like the part G. It's a little bit more involved. So it's the integral of a 2x cube root of x squared plus 6 dx. You have an extra job. The extra job is you have to switch the radical. Okay, you switch the radical, that gives x squared plus 6 to a third. But you move it up, it's going to be x squared plus 6 to the negative third. So this is going to be 2x times x squared plus 6 to the negative third. A couple of you missed it on the quiz. I think there was a radical x down the denominator. You move it up, it's going to be x to the negative 1/2. Any question? See, it's the same thing now. As soon as you switch the radical, it's going to be the same one. So you take the u to be x squared plus 6. You find the du, which is a 2x dx. Then you go for the dx, which is a du over 2x. Go back, substitute. If everything's all right, you should get u to the negative third. So 2x times x squared plus 6 to negative third dx. Substitute. You don't have anything for the 2x. Don't worry. It's going to be canceling out. So we get the u to the negative third times the dx, which is a du over 2x. So the 2x and the 2x would cancel out. So what's the leftover? The leftover is going to be u to the negative third du. You move up the power, so it's going to be u to the negative 1/3 plus 1 would be 2/3 over the 2/3, a constancy. You flip the 2/3 into the 3/2, u to the 2/3 plus the c. So you substitute 3/2 x squared plus 6 to the 2/3 plus c, and then you're done. Any question? So that is involving, the radical function, rational function with different parts. And you have one unique case with the exponential one. You cannot have anything else for the exponential one for the time being. And that's the part t, integral of x cubed e to the x to the 4th. You see, we talk about it, we can only integrate the e function. So you have to change this one into the e to the u, the formula that we gave you. You see, this is, you are going to use this last formula, integral of e to the u du. It's going to be just e to the u. So for the substitution method, you have to take the u to be x to the 4th. Okay, u to be x to the 4th, and you should get to the, when you simplify it, you must get e to the u. So differential of the u, 4x cubed dx. Okay, you find the dx, which is going to be du over 4x cubed. Go back, substitute, simplify, show that you are going to arrive at e to the, okay, e to the u. So this is the original one. We substitute for the x cubed. We don't have anything for the x cubed. E to the x to the 4th is u dx. So the dx would be the du over 4x cubed. So the x cubed and x cubed would cancel out. The leftover, a quarter. So you put out a quarter, e to the u du as you expected. And you know that integral of e to the u would be just e to the u. So it's e to the u plus c. You substitute for the u, so that gives you x cubed plus c, the final answer. Any question? So we give a true question. We put all these 5 or 6 cases together as a method of substitution, and on this quiz and on the final. Okay, that's a type 1 of the integrations that you are going to know, you're going to have. Okay, so that would be area between two curves that we talk about it. Okay, what's your question? Where you determine the u? What do you mean?
I'm just a little confused about like where do you define the u? Like other times, let's say you use as x squared plus 6, whereas this one, like if I was looking at it, I would choose like maybe e x to the 4th. Like how do you determine it's just x to the 4th?
Because this is very unique one, you see, because your formula is what? Look at your formula. Your formula is e to the u. So this means whatever exponent is over here, you have to pick this one to be u.
So wouldn't it be ex to the 4th?
For what?
For the solution, you put 3.
Oh, I put 3? I'm sorry. Where is the 3? 4. 4. Thank you. Okay, for the exponential one, you see, because the formula is e to the u. So you have to pick this one to be u. Anywhere else, you see, this is just a power function. You see anywhere else, a parenthesis, u. Okay, there's going to be 2 cases that, so look at this one, is this power function, u to the 5th, okay? The only part that you stay where you are, this is where there is no power. So that give you 1 over u, because our formula would give us a 1 over u. For the exponential function, you have to take the e to the u. Okay? So this is where you do the substitution method. That's case 1 for the integrations. Okay? So case 2, these integrals that you add the constancy is what is indefinite integral. The result is a function. The next one is the definite integral or the Riemann integral. The Riemann integral must be, the result would be a number. So that would be the second one that we're going to be interested in. Everything we did before, it can happen with the, okay, with the definite integral or the Riemann integral. Definite integrals. In this type of integration, you are going to be given this one like a to b, f of x dx. You realize this is a definite integral. We know that the result must be a number. We use fundamental theorem of calculus, which means you forget about a and the b, you integrate it. The result would be a function like f of x, then we evaluate it from a to b. So this means we plug in x equal to the b first, minus x equal to the a. That gives you the final answer. Okay, definite integral. So the cases that we're going to be interested in, remember we have 2 types of integrations. The one that you need u substitution and the one that you can do it straightforward. So you should be able to do both of them for us. One from each. Okay, any question? That's your tool. So 2 cases, ordinary one and the substitution type. Ordinary one is part 1. We give you 2. Okay, this is one. No substitution is needed. So integral from -1 to 2. -1 to 2 is a 4x cubed. 4x cubed minus 2x plus 1 dx. As soon as you see the -1 to 2, you realize that this is a definite integral. Okay, integrate it. You don't need any substitution because it's just powers of the x. If any radical, you change it, any fraction, you change it, nothing, so just go for it. So this is going to be the case, integral from -1 to 2, 4x cubed minus 2x plus 1 dx. You integrate, 4 is a number, move up the power, x to the 4th over 4. 2 is a number, move up the power, x squared over 2, 1. You know that integral of 1 is just 1x. Don't add the constant c. You evaluate it from -1 to 2 with this notation. Question, simplify it first if you can. Then do the evaluation. So you end up with the x to the 4th. Okay, x to the 4th minus x squared plus x to be evaluated from -1 to 2. Substitute 2 first. So it's going to be use parentheses 2 to the 4th minus 2 squared plus 2 minus, open up the parentheses and try the -1. Always use parentheses. So the -1 again, -1 to the 4th minus -1 squared is going to be just -1 or -1. Simplify, 2 to the 4th, 16, 2 squared, 4, 2. Inside, -1 to the 4th is a positive 1. -1 squared is a positive 1, but there is a negative here. Okay, and the -1. So this is it, that gives you 12, 14. Minus, inside, 1 and 1, -1 cancel out, you get -1. So that would be a -1, and there is a negative outside. Now let's write it down. So that gives you 14 plus 1, which is equal to 15, the final answer. Okay, the result must be a number. So you don't have to, but I rewrite it, -1 to 2, 4x cubed minus 2x plus 1 dx is equal to the 15, definite integral. Any question? So that's case 1. Case 1, no substitution is needed. And we are going to have 2. Case 2 is the one that we need use substitution. You must recognize it yourself that you need a substitution method. Okay, it's like part B and the C. So part B. You see integral of -1 to 3. -1 to 3, square root of 1 plus x dx. See this one? Again, is a -1 to 3, so it's a definite integral. But we have to switch the radical. So that will give us 1 plus x to the 1/2. So you have to use the substitution method to take care of that one. Okay. So you rewrite it first. You say, oh, this is a -1 to 3. And then I have to go 1 plus x to the 1/2 dx. So you need a substitution method. Okay. So you have to take the u to be 1 plus x. And you end up with the u to the 1/2. Okay. Let's see. Differential of the u. Derivative would be just 1. So it's a 1 times dx, if you like. 1 times dx, which is the dx. So the dx is du. Now, you have something extra to do. That's it. That's where you got to be careful. You see, this function is function of x. So x is between -1 and 3. When you do the substitution, you put u equal to the 1/2. And this would be du. So that would be u function. You cannot say the again in -1 to 3. So what you do, you have to change it. So before going substituting, you say, oh, when x is a -1, extra job. When x is a -1, if you substitute here, so u would be 1 minus 1 equal to the 0. when x is equal to 3. You substitute here, so your u would be 1 plus 3, which is equal to 4. So the integral from -1 to 3 would be changed into the what? 0 to 4. So this is the one you got to be careful, okay? So I do the substitution now. So I have -1 to 3, 1 plus x to the half dx equal to integral of the -1, the corresponding number is 0. +3, the corresponding number is 4. 1 plus x is u, so that gives you u to the half. Dx and the du are going to be the same. You see, we switch it into the substitution part, and at the same time, we bring the proper limit of integrations, which is 0 to 4. You cannot use the same number. You got to be careful for this one. Otherwise, the rest are going to be easy. So that will be u to the 3/2 over the 3/2, no constant c, integral going from 0 to 4. You flip this number, it's going to be 2/3 of the u to the 3/2 from 0 to 4. You substitute. Any question? But make sure you don't miss this part. Okay, you have to put the 4 and the 0. If you put the 4, so that gives you a 2/3, 4 to the 3/2. When you put the 0, the result would be 0. Okay, so you have to take care of this one. 4 to the 3/2. 4 to the 1/2 would be 2. 2 cubed would be 8. So I put it on the top. It's going to be 2/3. Okay, 2/3 times 8. 4 to the 1/2 is a radical 4, which is 2. 2 cubed would be 8. So the result would be 16/3. The final answer. Okay, any question? So be careful for the definite integral. When it's a substitution method, you have to use a substitution. You have to change the reverse this is sign of the integral to get this number done. Yes, what's the question?
So is it okay if we just take the 1/2 and add that to 1 and kind of like skip all of that and just get directly to it?
No.
Okay.
We want to make sure you do it because it's the first time that you do this number of numbers. Okay, you can do it on the final exam, not on this one. I know what you mean. Okay, yes, this is eventually what we do when we get to the calculus too. But in this, we want to just make sure to get the meaning of the substitution method. You see, you will miss the u and the du, etc. That's the purpose. Okay, you saw that we use this type of methods, integration by parts. Okay, so you have to show your work. That's it. That's the idea to get it. Okay, so this is going to be the case. But if you do it on the final, I accept it, not on this quiz. We want to practice first. Okay, I used to teach only that shortcut in Calculus 1 all the time. Okay, but then when they get it, in your case, you're done. But when they get to the Calculus 2, they say, oh, you should tell them to, to keep this this method, for integration by parts. But I accept it on the final. Okay, so one more topics to remind you, the average value. Remember, that is going to be kind of application problems that will give you some shortcut. You can use it, accept it. So the other concept we are going to be interested in is what? Average value. Must know the formula. What was the average value formula? Remember, average of f is 1 over b minus a, integral from a to b, f of x dx. So a function would be given to you, okay, it's going to be average of something. You see, you do some businesses, especially average revenue, average supply, etc. Then, so it's like integration, but you have to divide by 1 over b minus a. Okay, for application problems, I told you that most of the time you are going to have exponential type function. Okay, so I let you use this formula. I talked about it the other night, I think. So if you want to find the integral of e to the a times x dx, a only. Okay, 2x, 3x, 5x. You know that the e function won't change, it's going to be e function. But we usually, when you differentiate, we have the u prime. U prime is a. We multiply by a. In the case of integration, you divide. So that gives you integral of e to the ax, okay, divided by a plus the constancy. I'll let you use this one for these type of problems because this is frequently these type of functions are going to be used. Just want to make sure you know it. Any question? So because of this, I'm going to do number 4 for this. Number 3, I did that function h of x for this type. Okay, so what I do the number 4 for you. This is one application problems that we are going to give you. So in number 4, you have a so-called a price supply function. You see p or s of x is given to you. It's a 10 times e to the. Okay, want to make sure we give you one application types problem. So it's s of x equal to the 10 times e to the point 0 to x minus 1. Okay, so x is going to be the demands, okay, the number of the items that you're going to have. This is going to be the number of the items that you have. This price demands equation, remember? Your price demand equation, you use it to find the revenue. It's the same thing. So it depends on the demands, you are going to change the price. So what we would like to do is, we'd like to find the average price in dollars over the supply interval of 400 and the 600. Okay, so the supply is X. So in this period, you're producing something between 400 units and the 600 units. You want to know how we're going to change the price. Okay, so in this type of problem, so you would like to find the average price or supply, average price. So the average price, the formula is going to be what? 1 over b minus a is going to be 600 minus 400. Okay, and you're integrating from 400 to the 600. Okay, 400, 600, the function. So what's going to be your function? Your function is going to be 10 times e to the 0.02x minus 1 dx. We want to check how patient you are. Most of you were patient on that problem that I give you. Remember, I think problem 8 or 9 about the percentage of the alcohol in the blood or something. And most of you did very well. Some of you missed it when you use your calculator. So just double check. You have 1 on the final review. We are going to check it. Okay, so this is going to be the average value. This function would have something extra. So let's simplify it first. It's going to be 1 over 200. Okay, 200 integral from 400 to 600. And to integrate it, I just have to repeat this one once more. So what we're going to do, you can pull this 10 out. So that gives you 10 over 200. Then you can simplify it. So that gives you 400 up to the 600 e to the 0.02x minus 1 dx. Any question? Now, to integrate it, that shortcut would be very useful. So what we're going to do is we can simplify these two first. Okay, so that gives 1 over 20. Then you integrate it. We integrate the e function first. We talk about it. This is going to be what? You repeated the e 0 2x, but remember divided by that coefficient divided by a. So in this case, it's going to be divided by 0.02. Okay, 0.02 minus what? Integral of 1. You know that integral of 1 is x. Is x, but to be evaluated from 400 to the 600. Any question? And so, you know, that will be, otherwise we have to use substitution. You know, it's going to be messy when we get this one. It can be done. And so, what we can do is we can multiply it if you like, then substitute, or just substitute as is to get the to get the result. You have to use your calculator. And so it's going to be 1/20. If you want to keep it as is, you will use a bracket here. Okay, then substitute 600 first. So this is going to be e to the 0.02 times 600. And you have 0.02. And this is going to be minus 600. Okay, this is when you put x equal to the 600. Then it's going to be minus, open up the parentheses, and repeat it again for the 400. So it's going to be e to the 0.002 times 400. Okay, divided by 0.02 minus, okay, minus 400. See, this is going to be the one. Be patient, be careful about these negative signs. Okay, question, we just substituting. So go on inside, put them together, and eventually use your calculator. So this is going to be e to the, this is easy, 2 times 6 would be 12, 1200. That make it into 12 because of the 2 decimal places. Okay, and this is going to be 0, 2, and that's minus 600 minus. Now this would be e to the 2 times 4 would be 800. So that make it to the 8, and this is going to be 0.002. And negative would be positive, so that make it to the positive 400. Okay, so it's going to be equal to the 1/20. The E1 are going to be, you see, you can put these two together and just use your calculator to take care of it. So it's going to be kind of, if you like, you can write down as E12 minus e to the 8, or just use calculator. 0.2. And that's a negative 600, and the 400 that give you negative 200. Okay, then you know we can use calculator to get these. You have to use your calculator to give us these numbers. Okay, so let's see. You can try it yourself, but to see, I go with the exponential function, so it's going to be second and the ln e function. So I'm going to have e of 12. That's the first one, minus e, okay, e to the 8, e to the 8, that's a difference. Okay, so this would be equal to the, then I have to divide it by 0.02. So that is what I got so far. Okay, 0.02, then minus 200, minus 200. So this is going to be minus 200, and then I have to divide it by 20 to get these numbers. So if I divide it by 20, this is it. Okay, just try it to see if you get, if you get the same numbers. Okay, so my number is, so that would be the average price that I have is 399 424 0.5 or 0.6, okay, in dollars to get the average price. Did you check it? Anybody? Just make sure you get it out, you get it right. It's a big number, right? It should be correct. Get these numbers. Okay, what's the question? To get these numbers, how did I change from negative 400 to the positive 400? There is a negative sign here. You see, negative would be positive, because when you find the integral. Oh, okay, so you got the same number. Excellent. Null. And this is it. Okay, anybody, any question? So we give you one of these, okay, because these are the one that we usually use really in application problems for the average value, because those having those exponential format is the popular one, and one purpose is to check to see how you handle your calculator with this type of ideas that we're going to have. Okay, so this is going to be the one. Will be turning any more assignment after the quiz. I think I posted something for you. That would be your last time that you're going to give us the assignment, because we need only one more sets of assignments. I think I post something for you. I just double check it again, because we need one. And if I check, I'm sure that I did all the other section that I have. Otherwise, I will post it and we will collect it by the day after final, because we want to do a couple of these new problems that we did so far. Okay, so that's going to be number 4, and I did the 5, the area between two curves. Area between two curves. And the number 6 for the integration by parts, we just try one of them. There is one with the exponential one that involve more to talk about it. So we may not give you any integration by parts on this quiz. So we finish it, then we give you that on the final. So if we get time after the quiz, I may talk about that one too. Okay, so it depends how long are you going to take to give us that quiz, but probably I'll leave an interval to talk about it to finish it. And then we get the time to go over the final review. Okay, that's it. Any question?
Yes, so number 6 for the practice quiz, it's not applicable for Thursday's quiz, correct?
It is, but since we haven't done the second part, we are not going to give you one.
Oh, okay. Thank you.
Yeah, because I just give you those with the exponential function needs to be explained more. So I don't want you to be confused. No, after the quiz, I try to give us, we need, we do it. We better leave it so that we get enough time to concentrate on the rest, okay? Because the rest of them will be given. We need 6 questions, and we already got the 6. Because so that's it. The substitution method, or the 4 or 5 types. Okay, definite integral, ordinary type, and the one with the substitution method. Average value, that's the one that we did. We try to give you application problem with the average value. Area between two curves, the one that I talk about tonight. Okay, we give you 6 questions so that we get a little bit time so we can finish that integration by parts. Then we give you 2 questions on the final. Okay, that's it. Would I post what? Practice quiz? No, I did all the solutions. So what you need to post? I did all the problems. So study this. Okay, it's double bonus. I know that you can drop your lowest quiz and the lowest test. Forget it. Take this one first and then drop it, because that gives you the mood of the final to see how much time you can handle these, these new topics that we talk about. Okay, it's fine. You can drop your lowest quiz, and even you can, I mean, this is your right. You can not to take it, but my recommendation is take this quiz so that you will feel how you are going to operate. You try yourself how you're going to operate with these new topics that we have. So you better take it, and then you can drop it. Okay, any question? So I will add your points on that test that I graded. Then I check to see if it's kind of missing. I just put everything together. Then because we are, we're done. So I need to have all the information. And if there's going to be anything missing, just email me, then I'll check it for you. Be patient. Okay, have a good one. So Thursday, the quiz and a short discussion of the integration.